But I would like to thank Jamie for accepting my proposal. Okay, I just pinged him on Twitter and sent a couple of emails, and he kindly accepted my proposal. So thank you very much, Jamie. So if you don't know him, he's director of consulting at TypeSafe. So he's an Scala and AK expert. So he will be talking some JVM concepts right now. Thank you very much, Jamie.
Gracias. Me llamo Jamie Allen, soy el senior director de los servicios del mundo para TypeSafe, pero mi español es muy malo, so I'm going to speak in English. We have time for 2 presentations tonight, and they're both about half an hour to 40 minutes in length. And I'll have time to take questions. You can ask me anything you want. There's nothing that you can't ask me, and there's nothing that I won't answer. TypeSafe is a very transparent and open organization, so if you have something that you think is weird or questionable, feel free to ask me and we can talk about it. The first presentation I'd like to give is called What You Need to Know About Lambdas. And before I start, how many people are writing with Lambdas right now, whether it's Java 8 or Clojure or Scala or JRuby, so a fair number. And how many people like Lambdas? Okay, I'm going to upset you. And this isn't because I actually hate Lambdas. I joke around that I'm known for the person who hates Lambdas, but I really don't. It's just there are a lot of things about them that are difficult, and I want to talk about those things. So this is a presentation I gave at JAXConf in 2013. It really didn't need updating, so I didn't have a lot of time. But this is something, I've been coding with Scala and therefore Lambdas for actually 6 years now, since 2009. And I've really hurt myself in production and in testing because I thought I could write code a certain way. And then whenever I ran into problems, I didn't have good ways to fix it. So I upset Oracle greatly by giving this presentation right before Java 8 came out. Because they said, this is our big marketing push, and you are coming in and being very mean. And I said, no, I'm not. People need to know this before they start using Lambdas. And they agreed that all my points were correct, but they still wanted me to shut up. And I said no. So they're not mad at me, they're just not thrilled. So ignore this, I have a book. So when we're writing code, we want to write code that is very clean and concise and clear, and Lambdas are a great way to do that. At the same time, what are the trade-offs we're making when we use them? How can we be successful writing functional style code in Java 8 or Scala or Clojure or JRuby? I want to make clear that, first of all, I do love functional programming. And functional programming to me is not catamorphisms or monads or applicatives or anything like that. Those are all valid concepts that are in category theory, but they aren't necessarily functional programming per se. They're an implementation detail of functional programming, if you will. To me, functional programming is really 3 things. It's that you're being immutable as much as possible, and you have referential transparency. And by referential transparency, I mean, has anybody ever used string buffer or, I forget the other one, there's 2 implementations in Java where you have a mutable string implementation. If you type my name and you say, Jamie is a string literal, and you say, in a string buffer, reverse. Well, whenever I call reverse on this, I get a new string back, or a new string buffer back that has my name, a string, reversed, EIMAJ. And the problem is that if I then look at the original string buffer, it also was reversed. So that's not very transparent. That's a side effect. I didn't expect that asking to reverse when I would get a new string back would also change the original value. What we want is to be referentially transparent and get a new value back while not changing the original value, right? That's the sort of thing we want in functional programming. And finally, functions as first-class citizens. And the reason this is important is instead of writing code in the immutable style where you say what you're going to do, but you have to write all of the how, I want to write a function and apply it to a container of data. whether that container is a future, whether it's a collection, whether it's an option or optional, that's what matters to me. That functions are themselves a unique first-class citizen in the language. We want declarative code. We don't want to write code in this old style. This is how we did it in Java, and it didn't matter if it was Java 8 or Java. I would first, have some data. And then I would have a collection that I wanted to create to put the data into, right, whenever I'm done. And then I'd have some for each kind of structure here to say, for every value in my collection, perform some transformation and put it into the old collection. This is very much focused on how, and has very little to do with what. This is all that is what I want done, right? So we want declarative code that doesn't have all of this how garbage inside of it. So what is a lambda? It's a function literal. It's like creating a string and not binding it to a name or something like that. So it's an unbound thing that just exists. And that means that, like a string literal, it could be a constant or something like that if you wanted it to be, but nobody treats it that way. And it's really just an implementation detail itself of functional programming. You don't have to use lambdas to do functional programming at all. So this is how Java 8 looks. And it's much simpler, right? I still have the data that I'm creating to operate on. And then I say, for that data, I'm going to streamify it. I'm going to turn it into a stream so I can use the Java 8 Stream API. And then I'm going to map over the data in that collection. And map means I'm going to iterate over it once and transform the data somehow, right? In Scala, this would also be and return a value. But in Java, it isn't necessarily. This is the lambda here, and then I have to collect it back to a new list, which I'm assigning to this value here. And that's great. It's a little more cumbersome than I'd like, but it's still a lot better than having to write that imperative style code that we saw before. This is JavaScript. Its lambdas look kind of similar. You have some array list, and I'm doing this inside of Nashorn on Java 8. I'm adding some values into it just to have something to operate on. And then I'm applying a function, and I'm resulting in some new collection here. And it's a little more how-ish. It's a little more about how to do it, but it's still, applying a function to the data. Scala, I create the data I want to operate on. I map over it, and I perform a transformation inside of my lambda here, and resulting in some new collection of data, right? It's pretty clean syntax. Closure. Anybody here a Closure developer? Closure fan? Okay. I have my namespace. I might have an extra paren somewhere. Anyway, I define a main. This is actually a static because there's a dash in front of it, taking some arguments. And then I'm mapping over a data set. I didn't pre-create it here. I'm using it inside of the structure here, applying this function to every element in it. And a lambda in Closure is denoted by the hash sign. And then I'm also print lining, and the reason I'm doing a print line there is because Closure is lazy. And whenever it's lazy, it wouldn't actually do this work if I didn't say, here, make it do something. So I'm print lining to make the map happen. And then there's JRuby, which has also some pretty clean syntax. I've never really understood why JRuby didn't take off more, because there's so many Ruby developers in the world. And all you really have to do is put required Java at the top, and you can use your Ruby code in the JVM. That's pretty awesome. So I create the data I want to work on, and then I apply a function to it. Awesome. Pretty straightforward. So what's the problem with this? Well, there are some hidden issues that if you don't think about or know about, then you're going to have trouble in production, in testing, and in maintainability. So first of all, lambdas aren't reusable. Remember how in every case there, I had a block of code that only lived right there. And if I wanted to reuse it somehow, I would either have to copy the code and put it somewhere else, or extract it out into a function so that I could be dry and not repeat myself, right? They're not testable in isolation. If I want to test a lambda, I've got to test the whole method in which it lives and perform all of the tests specific to that Lambda right inside of the test for that whole method. And I don't like that at all. I just want to test that my adding 1 to every value results in the correct value. I mean, I know that's a really simple example, but I want to test these Lambdas individually. I don't want to have to test the whole method. So I can't do that with a Lambda. There's nothing I can refer to. There's no reference to it that I can use in my tests. And then there's this maintainability problem. In every one of the cases we looked at, you had to look at the code and read it to figure out what I was doing. It was simple because I was saying, you know, I'm just adding 1 to every value. But usually, Lambdas are not that simple. And people have to read through them and figure out what you're doing because there's no name to express what they do. And then I see this. And this is some Scala code I actually pulled out of a known framework that TypeSafe creates, Play. And I kind of, you know, mess with it a little bit to make it a little more clear. But it's Lambda inside a 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 Lambda. And that is bad, I think. Because when this blows up in production, I'm not saying it will, I'm just saying that if it did, I would have a very difficult time trying to find exactly where this was, where the problem was. That leads to a lot of people looking at your code with faces like this. Oh my God, what are they doing? I have to read through this whole thing and try and figure it out. The other thing about Lambdas that's really kind of crummy is they have lousy stack traces. Anybody run into this? Yeah. You see an exception because of something that happened inside of your Lambda, and you've got to really read through everything to figure out what's going on because it doesn't have a bound name. The compilers out there, whether it's Java 8 or Scala or Clojure or JRuby, they've got to come up with a handle. They've got to come up with a name for that, and they don't have any context for what you were doing, so they give it a name that doesn't make any sense. Let's have a look at some of them. In Java 8, it's this lambda $0. And imagine you had a class with, oh, I don't know, 15 lambdas inside of it. You would be looking at lambda $1, lambda $2, lambda $, etc., etc. And that sucks. Worse yet, in Java 8's implementation, there's this area where there's like a black hole, no information whatsoever. And they're going to fix this for Java 9, but right now, this is the kind of stack trace you get. I actually, first gave this talk when Java 8 hadn't been released yet, and I found a bug because it was saying line number 0, which was impossible because I have imports and I have to define the name of the class, and unless I wrote my code all the way across one line, that wouldn't have been plausible. And they didn't believe me at first, and I showed them the code and they said, oh, yeah, okay. But they fixed it. If you don't have a line number, and that just proves it's possible you won't get one, what are you going to do when it says lambda $12 with no line number? You're going to be struggling to find exactly where that problem was. JavaScript. Does anybody here like JavaScript? Yay. So if I divide by 0, which by the way was what I was doing here, right? I changed my lambda to instead add 1. I divided by 0, causing an arithmetic exception. If I divide by 0 in JavaScript, I get infinity and infinity. And I don't even know why. I don't know why I only have 2 values. I don't understand anything JavaScript is doing there. Which leads me to my favorite tweet of all time from 2010. That JavaScript doesn't have a dark side, but it does have a dimly lit room full of angry clowns that are wielding rubber mallets. They'll just beat you up. Which, is a big reason why we have people creating languages that are much more sane, like ClojureScript and Scala.js and TypeScript and PureScript, so that people can, at compile time, have assurances that their JavaScript is actually going to work properly. In Scala, our stack traces are a little bit uglier. In Scala 2.11 and before, we have to pretend that we had lambdas because we had to be compatible with Java 6. And being compatible with Java 6 meant that we couldn't leverage the method handles that were implemented in Java 8. So you see all this junk here that's kind of hard to read through. It's going to be fixed with Scala 2.12 where we are going to emit Java 8 bytecode. And if you want to use Scala 2.12, you're going to have to use a Java 8 runtime. But note, I still get the arithmetic exception, and what Scala calls it is a non-fun $1. Java 8, it's 0-based. Scala, it's 1-based. It's just not a lot of fun to figure this stuff out, especially in production stack traces. And then closure. Closures is especially interesting because remember, it was lazily evaluated. And that means that it's not going to be the last line that actually blew up. It's going to be where that line was performed, and you have to look through to find the exact place where your lambda was to figure out what it was. And in this case, it's calling it fn__10. I don't understand that one either. But at least, it tells me where to look with the line number, so, that's a plus. And by the way, the stack traces are so long in closure that I can't even fit it on the slide in this really small print. JRuby is particularly interesting about this. For known exception types, they actually trap them. And they give you a much cleaner view of what went wrong. But of course that has performance implications. Whenever an exception occurs, they've got to evaluate the exception, print out this pretty thing instead of just dumping the trace. But at least the trace itself looks pretty nice and tells you descriptively what happened. But for the kinds of exceptions that might occur that are specific to your domain, say you have something like a JSON parsing exception for your particular data or something like that, you won't get this. So they're also really difficult to debug. The worst case scenario is where you see people put multiple interactions on the same line. If I got a null pointer exception on this line of code, where do you think it is? I mean, it could be anywhere. So, a lot of people, because they want their code to be concise and clean, they'll just put everything on one line. But on the JVM, that's bad, because then you have to figure out which possible reference in here was null. So that's particularly tough. And just as a quick digression, I personally make the distinction between lambdas and what people call closures, because you can close over state from outside of yourself, from outside of your context. If you're doing that, I call it a closure. If you're doing just an ordinary lambda where its state is all inside of it, then I say that's a lambda. And here's an example. Using that number plus 1 thing, I defined the number first. And then I said number plus x inside of the lambda. I'm closing over some value from outside of itself, right? Well, the problem then is whenever you use lambdas with things that are asynchronous and not mutable or not immutable, then you might run into issues about time, right? You might have something happen at a time that you didn't expect when the value is completely different. And it's a very big code smell if you find yourself in a situation where you're closing over a value. You should never be thinking about it this way. You should always be thinking about how to encapsulate all of the stuff this lambda needs inside of itself. So, what do we do as a result? How do we fix this? From here on out, I'm going to show some really basic Scala, but I don't think it'll be too hard for anybody to read. It's just this very simple example code, right? What about named functions? What if we used functions that, we bound to a specific name? Would that be better? Well, maybe. I don't know. What will that do with our stack traces? You would think that the stack trace would now have a name to bind to show you and say, yeah, somebody's already shaking their head. And he's right. Whenever I use a named function, and this syntax is difficult even for somebody who's got a little bit of Scala experience, because I'm saying that I'm defining a function that is of type some integer value to, and this is inferred, another integer. It's an int arrow int. And that means that now I can apply the function inside of my map, right, and use the name. And now at least somebody reading the code can say, oh, okay, I know that that function is supposed to add 1 to the value. And I can test that in isolation as well. Those are all good things. But the stack trace still doesn't come out the way I wanted it to. It still says a non-fun $1. And I don't know why. But I named this thing. Why can't it tell me the name in my stack traces? That's no fun. Okay, well, what if we tried lifting a method? What if we, instead of using the val syntax, which is an immutable value of a function, instead we used an ordinary method? How would that work? Okay, well, let's have a look. In this case, I'm defining a function. I'm naming it. I'm using def, which is the syntax for defining a method in Scala. And I'm still using function syntax of an int to an int return value, right? And whenever I map and I use the name inside of there, it actually does come out inside of the stack trace. But what do you notice there? It says $1. And why would it do that? That implies that there's going to be multiple instances of this function. And the reason is because I did a def. If I did a val, that is evaluated once, right? At the time of creation of the class that it lives in. Whereas when I'd use a def, it's evaluated at the call site. Every time I call, it's going to evaluate the right-hand side of my equals. And that's why you're getting new instances every single time, which also stinks. You don't want to do that. That's just going to waste memory in your heap. So let's not do that, right? Let's try something else. As a quick digression, you can use something that programming language theorists, they call it eta expansion. And what that really just means is I'm taking a function and I'm taking a method and lifting it to be a function, right? And that means that instead of writing in the function syntax for the right-hand side, I can just write an ordinary method. And then it isn't treated as something that is evaluated on the right-hand side of the equals every time. It's just treated like a normal method. So whenever I divide by 0 and I get my stack trace, I no longer see a $1 or $sign anything. It's just bad function. You're not creating extra garbage, and you now have stack traces that show exactly what you want. So look closely at your stack traces and think about the implications of the $signs that you see in there that represent, extra allocations that are taking place. The allocations are cheap on the JVM. It's a garbage collection that will kill you. So I'll talk about that a lot more in my next talk. So what are the benefits of what I've just been talking about here? First of all, you can't close over a variable. Everything has to be an operand. Now, if you leave your method inside of the class where you're going to use it, you might be able to close over something inside of the class, like a field inside of the class. Don't do that. And if you must be absolutely sure that you can enforce that, take your function out of the class in which it's used. Therefore, there's no way it could possibly be closing over something. Put it in a companion object or something like that. And in doing so, closing over is impossible. The only thing that this method, the def bad function, the only thing it can use are the things passed into it, operands. That's good. You get better stack traces. Right? We just saw that finally we got rid of all that anon fun and lambda $sign and fn underscore or whatever. We get stack traces that show us what we're used to seeing pretty much from ordinary Java stack traces. It's also more debuggable, right? I can put breakpoints on this the same way I did other stuff. Now, mind you, this isn't quite the problem it used to be. Years ago, debuggers didn't have any idea how to deal with map and couldn't show you stepping through the iteration of a collection or whatever container you're using. Nowadays, they're much better, and they can do that. But it's still much more debuggable and more testable. Now you have something that you can reference and test it in isolation all by itself. That's a big win. But it's also more maintainable and descriptive. People reading your code, assuming you give good names to your stuff, don't have to go off and try and read through all of this code that can be very complex and try and figure out what it is you're doing. And then you get reuse as well. Yay. So rule of thumb, reserve Lambda usage for just the simplest cases. If you're doing x plus 1, I get it. Go ahead, use a Lambda, whatever. It's not a big deal, right? But if you are doing anything significantly more difficult than that, pull it out. Make it a function, make it reusable, make it testable, because you're going to want to test that. You're going to want the good stack traces. This is all a win. I don't know why the slide went dark there, but language creators, and this is on the Clojure community, the Scala community, the Oracle. We all have to do a better job of giving you the tools that you need to survive in this new functional world that we're all living in. At TypeSafe, we've been working really hard on it for years, and unfortunately we're handicapped by the fact that we have to use Eclipse. It's nothing we can do. We don't make an IDE because we want to win the IDE wars or anything like that. The real matter is that, IntelliJ, for example, has their own language, which sort of competes with Scala. And if for some reason IntelliJ said, well, we're going to pull our support of Scala, there has to be an enterprise IDE for everyone to be able to use. Because otherwise the Scala's adoption would, fall. People wouldn't want to work with the language if they didn't have some tooling. So, we've been working very hard on Lambda friendliness, and this also applies to futures. Sometime this year, you are going to see a tool that comes from TypeSafe in the Scala IDE called Async Debugger. Has anybody heard of this? It is really amazing. So imagine you have a future which could have a Lambda inside of it, right? When you use that future, you're calling something that's asynchronous, and it's going to run on another thread, potentially. It may run on the same one, but neither here nor there. When it does, you can't just step into that code, right? Because it's going to run on another thread. You just can't walk that code through a debugger. But with Async Debugger, you can. They found a way to annotate the stack frames to provide information and allow for you to walk that future, just like it was synchronous code. That's mind-boggling. And then think about the implications for actors. You send a message. Another actor is going to receive it, probably running on a different thread. There's no way for you to follow that message, so we put a breakpoint over there. But then what if the message wasn't received? Where did it go? There's no way to track that. And you say, all right, Async Debugger, I can actually walk the message send forward and back. And I could see the state when I sent the message, and I could see the state after. It's just like walking through time. This is mind-boggling. So expect to see this hopefully by fall. We're working on it right now. So that's the first presentation. Is there any questions about my Lambda rant? Yes. Raul.
Regarding closures, so regarding closures, I get that they're dangerous and when they close over state, but is there a danger if the state that they close over is immutable?
There are even rules about whether the state is immutable. The question was, if you're using a closure and you're closing over some state, is it dangerous if the data is immutable? Theoretically, no, right? Assuming everybody follows that rule. I would rather make sure that nobody has the chance to make a mistake with it. And I think that Java actually enforces, Java 8 enforces that if you're going to use a value inside of a Lambda from outside of its context, I believe it has to be final. But we all know how that is. I could have a person type, and that person type could be mutable inside of it, but it's a final. I'll be talking about this a lot more next. Any other questions? Yes? Hey.
This new tool that you described, the synchronous debugger, is Akka team going to use it in the Akka testing? Are they using it there?
No.
As a tool?
Not yet. No.
Any ideas about that? Are they going to think about that?
I'm sure they will use it whenever.
Testing actors is really difficult sometimes. So.
Oh, absolutely. Yeah. So, writing tests for actors is kind of unique, right? Because, first of all, you want to test whether or not the business logic inside of the actors is what you want, right? It has nothing to do with the dynamics of message sending and asynchrony or anything like that. But then you also have to test message sending and getting the correct value in response to it or something along those lines. I found Akka Test Kit to actually be really usable. Do you want me to show an example of it?
No, just curious. I mean, what we have now, it's actually working, but what you described is much more interesting. And
yeah. Well, and that's just it, right? I mean, if a test fails and you can't see why a message wasn't received and you didn't get the response back,
right.
What are you going to do? You're going to end up putting, printlns or logs or something there, trying to figure it out. But, for the debugging session, I see that as separate from the testing concern. That's just you sitting there trying to figure out where things went and follow a message and walk the progression of interactions, right?
Well, actually, it would be especially interesting for messages in time when you want to see what comes first, second, whatever.
Yeah.
Well, actually, thank you.
Yeah, definitely. Interesting point. So one of the big gripes people have about Akka is the fact that message sending is untyped, right? I can send any message I want to any actor, and there's no way at compile time to enforce that that message can be even received by an actor. And people complain about that because A, we call ourselves type safe, and B, it makes it really hard to figure out when things go wrong. That said, has anybody seen Roland Kuhn's typed actor implementation that's already in the master branch of Akka? This is mind-blowing stuff. People have been working on this for 30 years and nobody has been able to figure out how to do an actor implementation that was actually statically checked to prove that when you send a message to an actor, you will be receiving that on the receiving side. That's incredible. It comes with some consequences though. Even though you can say that an actor will receive this message type, you cannot enforce that the actor will receive that message at the time it's received. And there's no way to do that because actors can switch behavior. So I receive a start message and that's the only message I'm listening for. And whenever I get that start message, I switch the behavior that the actor uses to evaluate messages that are coming in. And that means I'm not listening for start anymore, right? So if I tried to send a start to it, I mean, it would compile check that this is something that you could send to an actor, but it wouldn't enforce that at the time you sent it, it was going to be handled. So that's always, I think, going to be a unique edge case of actors. But the benefit of it is so worthwhile, being able to build state machines, right? That only respond to certain kinds of messages at a given point in time. So, we're okay with that. I think just having the ability to say at compile time that you're going to be able to handle this message is going to be a big win. Any other questions? Okay, that was pretty quick, huh? Hard to believe that was once a keynote.